Hey guys, welcome back to another problem solution video. Today we have yet another question from the COMC. Let's first begin by reading the question. So, a rectangle ABCD has diagonal length of D and the line AE is drawn perpendicular to the diagonal BD. The sides of the rectangle EFCG have lengths n and 1. Prove that D to the power of 2 over 3 and n to the power of 2 over 3 plus 1 are going to be equal to each other. So, let's first start off by looking at some things on our graph here of the rectangle. So we can see that here, this side is going to be equal to 1, and this side is equal to n. Now, I'm going to make a new variable for this side here, BG, and we'll label it as x. This means that here, for side BE, since this is a right angle triangle here, we see that this side right here should be square root 1 plus x squared. And we'll be working with this for now. So here we can see that triangle EBG is going to be similar to triangle BAE. So why is this? Well, we can see that they both have a right angle here, and this angle plus another angle is 90 degrees. This angle plus another angle is also 90 degrees, and hence they are going to be similar triangles. So let's start it off by writing down our equation. So this means that triangle, I'll write it here, triangle ABE is going to be similar, so not equal to, similar, is going to be similar to triangle BEG. And here, so we see that EG, our little length on top, is going to be similar to side BE, and side AB is going to be similar to side BE. And so now we can write out our ratios, which is that AB over DE should be equal to BE over EG. Now, because we know that BE is going to be equal to 1 plus x squared in the square root, and that EG is going to be equal to 1, we can see here that AB is going to be equal to BE squared over EG, which is going to be equal to x squared plus 1, or 1 plus x squared. So now I'm going to write down here that side AB is going to be equal to 1 plus x squared. Okay, so now that we have this, let's start looking at what DF and BC could be equal to. Now here, we can see that this is side DF, and this is side BC. Now we know that DF here, as you can see, DF here, DF plus FC should be equal to AB. Or in other words, I can write this the other way, so that DF is going to be equal to AB minus FC here. And you can see that FC and EG are going to be equal to each other, so FC is also equal to 1. And so DF is just going to be equal to AB minus 1, which is going to be equal to x squared. Meanwhile, BC here is just going to be equal to AD, which is going to be equal to x plus n, so the n from here. Now that we have this, we can look at these two new similar triangles, so BGE and EFD. So we have BGE, which is going to be similar to EFD, and this, the ratio as well from before, is going to be x over n, is going to be equal to 1 over x squared. And so, n is going to be equal to x to the power of 3. Okay, so now that we have this, we can then begin to look at what d squared would be equal to. Now, since this is d squared, so d is the diagonal here, we can see that d squared, it should be equal to dc squared plus bc squared, so a right angle triangle here again. This means that d squared is going to be equal to bc squared plus ab squared. And that this here is going to be equal to, plugging in the values that we saw from before over here, is going to be equal to x plus n squared plus 1 plus x squared. So now we're going to expand this into x squared plus 2nx plus n squared plus 1 plus 2x squared plus x to the power 4. And this here is going to be equal to, as we plugging in the fact that n is equal to x to the power 3, this is going to equal to x to the power 6 plus 3x to the power 4 plus 3x squared plus 1. And here we can see that this is actually going to be numbers here, so the coefficients, so 1, 3, 3, 1. This is actually the third row of the Pascal triangle. And this means that this equation here can be then factored into x squared plus 1 to the power of 3. Now that we have this, we know that this here is also going to be equal to d squared. So I already wrote it up top here, but I'm going to move it down so it looks easier to see. Now that we have this, we can see that d2 over 3 should just be this, but cubed. So this is going to be equal to x squared plus 1. And funnily enough, x squared, since n is equal to x to the power 3, as I wrote in here, n is equal to x to the power of 3, we know that x squared is just going to be equal to n 2 over 3 of it plus 1. And so this clearly shows, this is proof that, as here, d2 over 3 is going to be equal to n 2 over 3 plus 1. And so that's the answer, or the proof. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.